I'm going to do each of these 3 example problems, 1, 2, and 3 here, with you, just in case you needed a little bit more help on how to find the curve and line of best fit, and then how to use it to make a prediction. So this one says that a scientist dropped an object from a height of 200 feet, and so that's the height, that's our y value there. Find the equation of the curve of best fit, then predict how high the object will be after 3 seconds. So you can see this is the time. We want to figure out basically the next step in this table. What's the x value? Oh, sorry, what's the y value when the x value, when the time is 3 seconds? So I'm going to edit my 2 lists. You can clear the entire list by just going up to list 1 and then hitting clear. Don't hit delete, otherwise the entire list goes away. You're going to hit clear. And then type in 0, 0.5, 1, 1.5, oops, 2, 2.5, and then all of the heights. And now I'm going to, actually let's just change my zoom to fit it right now. So that shows me the scatter plot. To find the actual equation for my line of best fit, I hit stat, you go over to calc, and it's asking for a curve of best fit. That's important. It's asking for a curve of best fit, which really means that I'm looking for a quadratic to represent or model this data. So I'm going to go to quadrag, option 5 down there. It's using list 1 and list 2. I'm going to want to look at my pictures, so I'm going to store this in for y1 and then hit calculate. So that is my equation, or at least those are my coefficients for my equation. So when I put that together, that is what my curve of best fit equation looks like. The a goes in front of the x squared, the b goes in front of the x, and then the c is just the constant. That's really the starting height. That's close to our starting height of 200 there. That's what it is at time 0. Now I want to figure out what it is after 3 seconds. So again, you could just take 3 and plug it into your x's in the equation. Since I have my graph all set up with that curve of best fit, I know that the calculator can find it easier by just using the value function. You hit second, trace, and then value, and I can just type in 3 and hit equals, and of course that's invalid because I am zoomed in too much. I'm going to zoom out a little bit. That shows a bigger picture, just so it's going to catch 3. Right then, 3 wasn't actually on the graph, so it was saying it's invalid. Now I should be able to do it. Second, and trace. And again, calculate 3. So my y value at that spot is 55. So it is 55 feet high after 3 seconds. Number 2 says the data represents the average farm size over time. So this is the year. That's going to be my x value. This is the average acres per farm. So you can see it starts at 434. It goes up, 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 up. Still going up the entire time. So actually, the farm size is going to increase the entire time. That's why this is not going to be a curve of best fit. The first question kind of tells you it's not going to be a curve. It's saying, what is the line of best fit? This is a proportional relationship. As the years go up, the acres go up. So it's not going to go up and then come back down like a curve of best fit. It's just going to be a line of best fit. So I'm going to type in my data. I'm actually just going to use 0, 1, 2, 3 for the years. It should not change my equation except for where the graph starts. So instead of using 2007 and then having to zoom in all the way over to 2000 on the x-axis, I'm just going to use 0, 1, 2, 3, 4, 5, 6, 7. And the graph is just going to start at the origin instead. No, not really at the origin, but at this first coordinate, which is on the y-axis. Okay, so I got my 7 points in there, and now I want a line of best fit. So I'm going to hit stat, go over to calc, and then go down to linear regression. It's just making a line of best fit in slope-intercept form. So I'm using list 1 and list 2. Again, I'm going to store this just so I have it in for my graph, and then I can plug in my value a little bit easier. So I'm storing it in for y1, and it just replaces the equation that was in for y1. Calculate, that gives me my slope and my y-intercept. So that's my A, that's my B, and I'm just going to type that out. Y equals 2. Let's just call that 2.1x plus 433.92. So that is my equation of my line of best fit. And now this one might be easier to just figure out that 500 acres by plugging it in. But this is asking, using the line, around what year would the average farm size be 500 acres? So this isn't actually asking us to plug in for x now. Actually, we can't really use the calculator function there. So the easier way to do this is basically just solving the equation. 500 equals 2.1x plus 433.92. And then I'm going to solve that equation for x. So I want to get x by itself. So my first step is going to be to subtract 433.92 from both sides. That would give me 66.08 equals 2.1x, and my last step is to divide by that 2.1. And that'll tell me the year after 2000 that it'll take for me to get up to that acreage. So it's about 2031, almost 2032. Let's say 2001, 2031.5. The last example problem says the table shows the horizontal distance in feet traveled by a baseball hit at various angles. So the distance is here. This is how far the baseball is going. And the angle is here. It's at 10 degrees. When you have a fairly level baseball bat, it's going 115 feet. When you increase the angle, it's generally going to increase the distance up until about 45 degrees, and then it goes back down. When your bat angle is about 45 degrees, that's when the ball is going to go the farthest distance. And actually, that's generally true in physics. When you have a 45-degree angle as the launch angle, that's going to give you the greatest horizontal distance. So I'm going to type in my two lists. I'm going to clear out list 2 and list 1 first. Make sure you type these in carefully. This can mess up your entire curve of best fit just by typing in one number incorrectly. So I got my x values. So now I have my two lists in there, and it's asking what's my curve of best fit. So I want a quad reg. I want to hit stat and calc, and I want a quadratic regression. That's really what that stands for, quadratic regression. All of these are regressions. One is a line, one is a quadratic, this one's a cubic, that's a quartic, I guess that's the suffix there. But they're all regressions showing the relationship between the x and the y. So I want a curve of best fit, and I'm going to store that again, variables, and then y variables, and type it in for function y1. And this is my equation, or at least my numbers that go into the a, b, and c in the equation. And so that's how I'd write out the full equation. I'm not going to try to cram it into that box, but that is my quadratic that describes this relationship. This is saying, well, letter B is saying, based on the quadratic model, how far can the ball be hit? That should be the word hit, at an angle of 71 degrees. So this is the x value. I could just plug that in, put 71 in place of both those x's, and then follow order of operations to figure that out. But since I already have my quadratic in for y1. I'm thinking I'm going to have to zoom out a little bit to actually use the value function. I'm going to hit second and trace one more time. Nope, I missed it. Second and trace. And then use that value function, figure out what the y value is when the angle is 71. So the y value, or the distance, is 133 feet. 133.41 feet. That's how far the ball can travel when the bat angle is 71 degrees.